Hello, algebra students. Welcome to lesson 7 of Algebra Essentials. Today, we are going to be multiplying algebraic expressions. Now, this is actually one of 2 classes we'll do on multiplying before we put together all our addition, subtraction, and multiplying in algebra rules. But today, I want to really focus in on a couple of patterns and things we've learned before and how we are going to use them in this context. We also have a student with us here today. That's Annette, and she's going to be making sure that I make sense. So first of all, I want to know, Annette, if you've ever noticed a little pattern. I want to compare 5 times 6 with 6 times 5. I know, sounds silly, right? But I promise I'm going somewhere with this. What is 5 times 6?
That would be 30.
Brilliant. How about 6 times 5?
Well, that would be 30 as well.
That would be 30 as well. I agree. Same numbers, different order, but I get the same answer, don't I? Let's try the same thing with some negative numbers, and you could use your calculator if you wanted to. What is 3 times negative 11?
Negative 33.
Brilliant. Now let's compare that to negative 11 times 3.
That is negative 33 as well.
So I'm looking for a pattern here. If I change the order of the numbers I'm multiplying, does it make a difference to our answer?
No, I don't believe it does.
It doesn't. That idea that order doesn't matter when multiplying has a name. You don't have to have this name memorized for the GED, but you do have to notice the pattern. The commutative property, I always think of it like if you do your commute to work, you're moving around. When multiplying, if my numbers move around, they commute, I'm still going to get the same answer. So I want to look at groupings when multiplying. So same basic 3 numbers I have multiplying here, 7 times 3 times 5, but I'm grouping differently. If you remember when we did the order of operations class, we said that we could force your hand about what operation to do first by using parentheses. Let's obey the symbols and deal with our groupings first. So on this first example, let's do 7 times 3 first.
Well, that's 21.
It is 21. And we can see by this example here from above that what is this 21 doing here? It's multiplying. 21 times 5. It's 105. Now, in the next example, they asked us to multiply in a different order. They wanted us to start with the 3 times 5, and they used those grouping symbols to explain that to us. So let's multiply in this order and see what happens. So what is 3 times 5?
That's 15.
That's 15. And so this is the piece that we've dealt with. It's still multiplying with 7, and 5 times 7 is 35. Carry the 3 into that tens column, and 7 times 1 is 7 plus 3.
We still have 105.
Glorious. So I'm looking for a pattern here. We didn't move the order this time. We changed the groupings. So we can see if you change the groupings, when all you're doing is multiplying, you still get the same answer.
Now we're using Gemma, right?
We did. We did our groupings first. But all I wanted you to notice here is even if I change your groupings when we're multiplying, we still get the same answer. And that's because it's only multiplication. If we had different operations here, that would not necessarily be true. But when it's all multiplication, if we change the groupings, we change the order of the numbers, we're still going to get the same answer. We have some power when all our numbers are doing is multiplying. This pattern has a name as well. This one is known as the associative property. Again, you don't need to necessarily know this word for the GED. It's not a vocab test. But what I do need you to know is this pattern. Whatever way I group and whichever ones I multiply first, I'm going to get the same answer in the end. Lovely. So 2 patterns that are going to be important to today's class, and then 2 things that we already learned about multiplication and exponents are going to be important as well. First example here, if I wanted you to multiply negative 11 and p, some unknown number p, do you know how to make that expression any simpler? In unit 0, when we were first looking at multiplication, yes, we use parentheses for multiplying, but it's not the way students think of it. It's actually parentheses with proximity, right? When 2 things are shoved together, they're multiplying. And so you can make this expression even simpler. You can drop the parentheses because it's just a number and a variable. By shoving them really tight together, I know it's like I owe you 11 p's. I don't have to p negative 11 times. And this just got a little simpler. Wonderful. And then same thing, if we have it in the other order, it doesn't matter. This one says h squared times 3. That h squared and that 3, the parentheses indicate that those two things are multiplying. And I can write that a little simpler. And once again, I'm going to write the number out front. And then we write the variable portion second. The number is called the coefficient. Again, not a vocabulary word, but I'm going to use that word a lot during class today. So I'd like you to know it. And then we often call that the variable portion. That's the h squared. And that would be the simpler way we would talk about that act of multiplication when doing algebra. Another way to think of it is literally just 3h squareds. H squared, how many times? Well, I have 3 of them. Just like you can think of 7 plus 7 plus 7 as 3 7s, you can think of h squared plus h squared plus h squared as 3 times h squared. It's weird, isn't it? Because we don't think of h squared as a number, but it is a number because h is some numbers. So h squared is some number. Like if h was 7, then h squared would be 49. It's a funky number, but it's a number. One more thing I want you to remember. So how to multiply numbers and letters is going to come up today, but also how to express repeated factors more simply. One way to think about 5 times 5 times 5 times 5 times 5 times 5. I could multiply that all out. But if I did that in my calculator, it would be gross. 5 times 5 is already 25. I had times it by another 5. I'm at 125. It's going to get nasty. So a lot of times mathematicians will choose to express this in a different way. More simply, really, than a long, ugly number. We will often use what to express repeated multiplication?
An exponent?
Exactly right. We can say what factor we have, what number multiplying. So in this case, we have 5. And then we could say how many times we're repeating that factor. We're repeating that multiplying. So let's see, we have 1, 2, 3, 4, 5, 6 5s multiplying together. And so we can use an exponent to say that factor is happening 6 times. So that also says 6 5s multiplying together. We read it as 5 to the 6th power, but that's what it means. And that would be a simpler way to write that. Now, don't let it freak you out if we apply that to letters. Again, a letter, this letter R, is just some mystery number. So it's going to behave like a number. So I can see that I have this repeated factor, this time not of 5, but of R. And I can still count up how many R's are multiplying, even if I don't know what he is. So how many R's are multiplying?
We have 7.
We have 7. And so that's the same as R to the 7th power. And that's certainly a simpler way to write this, whether or not I know what R is equivalent to or equal to. So other thing I want you to remember is we can use exponents to express repeated multiplication, or also known as repeated factors. Last class, we talked about terms. Those were numbers adding and subtracting. This class, we're talking about factors, which are numbers that are multiplying. Okay, so today we're going to multiply together uglier looking expressions, like, for example, 2x squared times 5x squared. And we're going to put together that order doesn't matter when you're multiplying, that groupings don't matter when you're multiplying, that we write our coefficients out front, and that we use exponents to express repeated multiplication. So now I said groupings don't matter. If you look at this first number, what does it mean? It means 2 times x squared, right? They're shoved together.
Right.
And if you look at this second one, it means 5 times x squared. So we have 2 numbers multiplying in there, a 5 and an x squared. But then look at this symbol here. You can see that entire 2x squared is shoved against that 5x squared. The only thing between them is this parentheses. So those two things are also multiplying. Yes, it's 2x squared times 5x squared. But another way you can think of this is as 4 numbers multiplying, a 2, an x squared, 5, and an x squared. They're all 4 just multiplying. Now there's a grouping. I'm telling you 5 and x squared first, but they're still all just multiplying. Now we said we can multiply in any order we want with any grouping. So we're going to use that to our advantage. First, we're going to take the coefficients. We're going to multiply those together like we always have. That's a 2 and a 5. Okay, so that'll be our first step today. We'll multiply our coefficients first. Now, we said when we talk about multiplication in the land of algebra, we put the coefficient, the number first, and then we put the variable portion second. So that's what we'll do. We'll do the variable portion second. But don't forget, we can use exponents to represent repeated multiplication. So that isn't just an x multiplying. If you see 2 shoved up against x squared, that means that's a 2 multiplying with 2 x's. Remember, x squared represents a repeated factor of x. And then same thing with the 5. That's a 5 with an x squared. That means a 5 with 2 x's multiplying. And so we have a total then of 1, 2, 3, 4 x's multiplying. And this is the weird part, and this is the part to take notice of, because what's happening with the exponent of 2 and the exponent of 2, those numbers in the sky, they're not multiplying, they're adding, because we're counting up how many times we're multiplying. I'm saying I multiplied an x 2 times, and now I'm going to multiply in 2 more x's. I now have a total of 4 x's multiplying. We'll look at it over and over again to help that to stick, because that feels a little tricky to students. But our exponents, when multiplying, will actually add. Let's just start real simple. We're going to simplify k times k times k times k times k. Any thoughts, Miss Annette?
But we go k to the 5th power.
Brilliant. Yes. This is a factor of k multiplying. How many factors of k do we have? We have 5 of them, 5 k's multiplying. That would be a simpler way to write that. Now let's get a little more complex. First thing I want to practice is simplifying 7 times 4a. 2 ways I can think about this, and we'll compare both ways as we try to see which way clicks for you. So one way to think about 7 times 4a is that I have 7, and those parentheses mean multiplying, times 4, and 4 and a being shoved together means multiplying again. So 7 times 4 times a. And I can drop the grouping, like I said, those parentheses, because groupings don't matter when we're multiplying. That's what we learned, right?
Right.
And I can multiply in any order I want here. Really simple. We can see that our coefficients are already up front. So 7 times 4 is?
That's 28.
28. And if I want to multiply together a number and a variable, or a constant and a variable here, I just write the number, the coefficient out front, and the variable portion second, shoved up together. And there we go. We get 28a. Now let's look at a visual. So let's think about what it means to have 4 a's. 4 a's is like I have an A, an A, an A, and another A in a bowl, right? We had our bowl full of A's. Well, if I have 7 of those bowls, that's what 7 times 4a means. Now there's a second, a third, a fourth, a fifth, a sixth, and a 7th bowl full of A's. And this is a pain in the butt way to do it, but it would be easy enough to see here. If I dumped these all in the same bowl, I would have 28 A's altogether. So next example, 8p times 6. Again, another way that I can think of this is as just 3 numbers multiplying, an 8, a p, and a 6. And since groupings don't matter, I could write it like that. We said we can also move the numbers around when we're multiplying. So let's do that to our advantage to do the number portion first.
All right. And that makes sense. That's what I wanted to ask you about that. If we could take 8 and 6 and multiply the 2 of those together.
Absolutely. I wanted to show you those patterns way back at the beginning of class. So I could prove to you that it was legal to do that. Just shift things around, just do them in any order I wanted. I need to show you that even though I'm not following the order of operations, I'm going to get the same answer.
Right. Okay.
Okay, cool. So 8 times 6 is what?
Well, that's 48.
It is. Now I still have one more factor in this sucker. I have this p that's multiplying with the numbers. And what do I do with variable portions when I'm writing algebraic expressions? I just shove them real tight on the back end with the number. Coefficient, number first, variable portion second. And I don't have an exponent this time because I just had a single p. Brilliant. And once again, we could picture that. We could picture 8 peas in a bowl. Okay, but I don't just have one bowl like that. I have 6 bowls like that. Peas are a thing. Yeah, they're a number thing, but they're still a thing. So I have 8 peas 6 times. Each one of these bowls has 8 peas. So I have 8, 16, 24, 32, 40, 48 total peas. Look, math could make sense. Now, where it throws students is when it's not just times 5 or times 7 or times 11, but we're actually multiplying together these algebraic expressions with algebraic expressions, where there's letters in both places. A little more tricky to visualize. And so we're going to rely more on that idea of just looking at these as individual factors. Look at A, 5x cubed times 9x cubed. Now, one way to think of this is a big ugly number multiplying with a big ugly number. Certainly. And that's what the parentheses say to do in this example. But like we said, each of those individual numbers we underlined has factors within it. So another way to look at 5x cubed, we have a number shoved up against a variable. That means that number and that variable are multiplying. So I can think about this like 5 times x cubed. We can see that 5x cubed is shoved up against 9x squared with the only thing between them parentheses. So that means we're multiplying. So I'm going to use that symbol for multiplying. And now we can see that 9 is shoved up against x squared. So that means they're multiplying. So I can write the 9 times the x squared. One way to think of this is 2 big ugly numbers multiplying. But another way to think of this is 4 smaller numbers multiplying. And we said we can multiply in any order we want. We can move the numbers around. And let's do that, first of all, to deal with our coefficients. We have a 5 and a 9. Let's go ahead and multiply those together.
45.
Now let's think about our x's. Those variables are telling us how many x's are multiplying. So yes, it's an x cubed, but that means the same as x times x times x. And yes, that's an x squared, but that means the same as x times x. So if I take the first 3 x factors multiplying and multiply it by the 2 other x factors multiplying, then I get a total of 1, 2, 3, 4, 5 x's multiplying. X to the 5th power. So take note, the numbers on the ground, they are going to multiply like they always have. I often say feet on the floor. Multiplication, of course, is multiplication like it always was.
Would I still be able to add the 3 and the 2, which would have came out to 5 anyway?
Exactly. That's the fast way. I'm not going to have you write it out every time, but I want to prove to you it's true and why it's true, so you'll remember it, and we're just going to start getting a little faster.
Okay.
So this is the basic rules that we're going to be following here. If it's got its feet on the floor, it's a regular number. It's going to multiply as it always has. But if it's in the sky, it's an exponent. It's telling us the number of times we're multiplying. So 3x is multiplying, 2x is multiplying. So we will add to multiply. So they call that the product rule, but we don't have to know that name. We just have to understand that concept. To multiply like bases, so that means that like they're both x's and x's, you actually add their exponents. Cool. Now applying that shortcut is going to help us do it faster. You saw where we were going in advancedness, Annette. I'm not going to write out B this time with all the little time signs. You and I know that one way to look at this is 2m times 11m to the 6th power. But another way to look at it is 2 times m times 11 times m to the 6th power. And so let's multiply together the coefficients. The numbers out front, they're regular numbers. They're just going to multiply.
That's 22.
Gorgeous. And now the m portion, the variable portion, that's repeated factors. I have some m's multiplying. Here, it doesn't have an exponent, so it's just a single m multiplying. Just like the invisible coefficient was a 1, if it confuses you, the invisible exponent is a 1. That's a single m multiplying. And now I have another 6 m's multiplying. That's what m to the 6th means. So now I have m's, but how many m's are multiplying now? Well, I had 1, and then I brought in 6 more. So now I have a total of 7 m's multiplying. And yes, we can see that that number in the sky, the exponent, they add. Now let's look at C. Here we have 6r multiplying with 4r cubed, multiplying with r to the 5th power. But same idea, you can think of it that way, or you can just think of it as a bunch of different factors. So everything with its feet on the floor is a factor. So there's 6, there's r, 4, r cubed, and r to the 5th power, all multiplying. And now we can apply the same order. We're just going to deal with coefficients first. Our regular numbers, they're going to multiply like numbers always have. Don't suddenly flip what multiplication looks like. So 6 times 4 is?
That's 24.
Gorgeous. Now, we have lots of r's multiplying. We have a single r right there. We have 3 more there. That's 3 r's multiplying. And then we have 5 more there. That's 5 r's multiplying. So we have a lot of r's multiplying. How many? 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 r's multiplying.
It looks so easy when you're doing it.
I'm so glad you say that because, I always say that at the end of class. It's always easy when the math teacher's doing it. To take it from the place where you look at it and you go, oh man, Kate explains things so well, to, oh man, I can actually do this myself on the test. Those are 2 very different places of learning. I can understand it when it's explained to me versus I can do it independently. And the difference between those 2 is independent practice. So if you're like, whoa, mind blown, go do the math ability. You can get a little help. If you're like, okay, this is making sense, it's time for you to do beginning level practice. But if you're like, hey, this is too easy, give me a little bit more, Kate, ramp it up. Stick with me. We're about to start our experience level practice. So next one says simplify. Leave your answer in exponential form. Now, what am I saying here? I say simplify. I want you to make it a little simpler. But when I tell you to leave your answer in exponential form, I'm giving you permission, even if the base is a plain old number, to just use exponents instead of multiplying it all out. So 9 to the 3rd times 9 to the 4th. Could I put it in my calculator? Sure. So 9 caret the 3rd power, then parentheses 9 caret the 4th power. And I'm not going to like my answer. 4, 7, 8, 2, 9, 6, 9. If I were going to multiply that all out, that's kind of gross. And quite frankly, not that simple. Like if it was 3 to the 3rd power, okay. 3 times 3 times 3, 27. But 9 to the 3rd power, 9 times 9 is 81 already. You want me to multiply it by another 9? And then you want me to multiply it by 4 more 9s? I protest. Nay, nay. I'm a mathematician, not an English major. I don't know how much time you think I have. And so that's why we let you use exponential form when simplifying, even with numbers, because it would be simpler to just express this as 9 to the 7th power, 7 9s multiplying.
That's exponential form?
Exactly. Exponential form means a base and a power. Your directions won't always say leave your answer in exponential form. Sometimes it'll just say simplify and you guys are confused. Why didn't they multiply it all out? Well, because some lazy mathematician said that's not simpler. That's grosser.
So it wouldn't be 9 times 9 is 81 and then that to the 7th power?
Oh, great question. No, think about what we did here. X to the 3rd would mean 3 x's multiplying, we had said, and that's multiplying with x to the 4th, which is 4 x's multiplying. And so all I'm doing here is counting up how many times I have a factor of x. How many times x is multiplying? 1, 2, 3, 4, 5, 6, 7. And so we say this is x multiplying 7 times. Same thing with 9s. Doesn't suddenly follow different rules. So 9 to the 3rd means 3 9s multiplying. I don't have to multiply it out. When I told you leave your answer in exponential form, I'm saying don't go 9 times 9. I don't care. I'm going to use exponents. So I'll just leave it like that. And we're multiplying by what? Well, 4 factors of 9, 4 9s multiplying. That's not 781s multiplying. That's still a base of 9. And how many 9s are multiplying?
It's 4, 5, 6, 7 9s.
I agree with you. If I just wrote 9 times 9, I could multiply those out, 81. But I could also write that as 9 squared. It means the same thing, 2 9s multiplying, or 81, I'll simplify it. So what I said to you when I said leave your answer in exponential form is you don't have to multiply out all those 9s. If you start multiplying out all those 9s, you got to finish it. You got to do it with 7 of them. Cool, good questions. I think a lot of people will wonder that. let's look at the next example, not with nines, but with J's. For some reason, variables are usually easier for students on these than the plain old numbers. So what am I saying by j to the third power? I'm saying I have 1, 2, 3 j's multiplying, and I would like to multiply in another j. Okay, that's 4 now. And then now I'd like to multiply in 2 more j's. Okay, 5, 6. I have a total of 6 j's multiplying. All right. What makes this an experience level? I mean, it looks the same as what we've been doing. Really, the only thing that makes it an experience is the negatives. That freaks students out, especially this one, because they're like, negative what? Why? What number is that? Do you remember last class we said that whenever you don't appear to have a number out front, there's an invisible coefficient? Do you remember what number that was? 1. So if it's freaking you out, realize that's a -1. And now, even if you don't understand negatives, you could put that in your calculator. You could do -3 times -1 times 4. Those have their feet on the floor. And notice in that, first of all, they're all different numbers. Do you see that?
Right.
It's
Yes.
not a repeated factor. There's no reason to use exponents here. And then secondly, none of these have an exponent on them. None of the numbers have an exponent on them. So they're not happening multiple times. So I'll just multiply them together like I always have. -3 times -1 times 4.
Well, it's the exponents got me going all over the place.
Careful, the exponents are weak. They're only working on what they're attached to. So this third power is not working on the -3. It's only working on the y. It tells me how many times y is multiplying. It doesn't reach across y and grab up other numbers. And then same thing here. This fourth power, it has nothing to do with the 4. It's telling me how many times the y is multiplying. So we said 4y to the fourth power means I have a 4 multiplying with 4 y's. There's not 4 4s. There's only 4 y's. And so that's why I could pull those numbers separately and deal with them separately. The coefficients are just regular numbers. They will multiply like they always have. Things would get weirder if I had exponents on the numbers, but I don't. So now I can deal with the repeated factors that have the exponents on it. And those repeated factors are not plain old numbers. Those repeated factors are y's. So let's look at just the y portions now. Here I have a y to the third power, meaning I have 3 y's multiplying. Here I have a single y. It's getting multiplied in. We can see that with the parentheses. And then here I have 4 y's multiplying. So I have a total of how many y's multiplying?
8.
Brilliant. So it's 12 multiplying with 8 y's. If I were to write it out, it'd be 12 times y times y times y times y times. I don't want to. That's not simple. I'd rather use exponents. This one is actually way easier than it looks. It says simplify, and it looks a little weird. Negative out front, then in parentheses, -0.9b to the 6th power. Now, we've actually seen this in much simpler examples. In the Crucial GED Basics unit, we talked about when you have the opposite of a negative. So I'm going to think of it that way first. We have the opposite of a negative number. What is the opposite of negative? Well, the opposite of negative is positive. And so I could just use that fact to say, oh, that's the same as positive 0.9b6. And that's the way that we've done it in the past.
Well, are you going to always change the negative to a positive?
If it says the opposite of a negative, that's what that says. The two negatives shoved together, or the opposite of subtracting. Either way you think of it, it's positive, it's plus. I'm going to take it back to a simpler number so you understand this. Have you ever had a bounce check charge? Like they'll charge you like $35 if you bounce a check. So I want you to imagine this is your fee from the bank. They charged you $35. You know what we do when they charge us $35? We would call in the bank. You would say, please, I need to feed my babies. I've had this conversation, right? Please reverse the charge. So now we're reversing the charge. What's going to happen to your account balance if they do it for you?
Well, it's going to go into the positive.
Bingo. Subtracting a negative is the same as adding, or the opposite of a negative, the opposite of a charge is a positive amount.
But how would I know to change these two negatives into a positive?
Math is always making things simpler. So if there's a simpler way to think of it, we're going to do it. We have two equivalent things. They mean the same thing. Write it in the simplest form you can. 9 plus 5 is 9 plus 5. What is it? It's 9 things and 5 things. But is there a simpler way to write it? Well, heck yeah. 14. That's the same as 14 things. Those two things are totally equivalent, but one's a simpler way to write it. So same thing here. You can take away a negative charge. It's not wrong. It's just not the simplest way to think of it, because you and I know what happens. Like practically, simply in our lives, how does it affect our lives? Our bank account balance gets positive 35. We go up 35. So it doesn't matter if this thing's ugly, or same thing's going to happen. If we reverse a charge, we'll end up with a positive number. So that's one way to think about it. But another way is that this is an act of multiplication. We said that when you have an invisible coefficient, it's a 1. Well, it doesn't even matter if there's a variable portion. This negative here means that this entire grouping is being multiplied by -1. If it's really freaking you out, fine. Throw your 1 there in front of the parentheses, multiply it out in your calculator, and you can see that -1 times -0.9 gives you positive 0.9. And then there's still 6 b's multiplying. I haven't jacked with that. If we like this way of thinking about it, rather than reversing a negative, we're reversing a charge. This way works as well. A lot of times there's more than one way to think about something in math class, and I don't need you to know them all. I need you to know the one that clicks with you. Beautiful. Now, this is not going to get any simpler. There's only one coefficient. All my repeated factors are accounted for. This is as simple as this is going to get.
That's it.
So I think basic thing is that if you have a negative outside of a group, it'll just change the sign of whatever's inside. So it's going to go either way. If you take the opposite of x squared, that x squared inside the grouping is positive, so you'll just end up with negative x squared. But if you take the opposite of negative x squared, it's already negative. We're going to see it turn into a positive.
I don't know why. Sometimes it seems like we're making algebra more difficult than it really is.
Absolutely. I would argue that algebra is often much simpler than basic math, because 9 times out of 10, we're going to just stop. That's all we can do with mystery numbers. We're going to stop. And you guys are so confused because you want to keep going. And I'm like, we can't keep going. We don't know what the number is. If somebody tells us what the number is, I'll keep doing some math for you, Miss Annette. But if nobody does, this is as much as I can handle with a mystery. Okay, so what is the product of -5/10 x? That's how you read that, by the way. I know we always say 0.5, but 5 in the tenths place. 3z squared and -7 4/10 y to the 4th power. Now, you don't need to be able to read those decimals aloud to tell me what it means to have a product. We learned that back in Crucial Basics too.
Multiplication.
Absolutely. It's a multiplication expression, or it's simplified, what you guys call the answer, but I actually call a simplified expression. So all I'm telling you to do here is multiply and simplify if you can. There are 3 ugly things, but there are 3 numbers I'm asking you to multiply. This one, and this one. We're mathematicians, not English majors. Let's write this using symbols. Miss Annette is getting so exalted because she is an English major. I think you're lovely, by the way. It's not. I'm just trying to stress that mathematicians are efficient. Don't get all wordy and we're like, dear Lord, isn't there a symbol we could use for this? -0.5x is multiplying with 3z squared, which is multiplying with -7.4 y to the 4th. Now, a couple of reasons why this might look nasty to students: the ugly numbers like negatives and decimals, and the fact that this time we have 3 different variables, but neither one of those are going to be an issue. We can deal with the ugly numbers in our calculator. -0.5 times 3 times -7.4. And I get 11.1. And now be careful. It's one of those cases again where I don't want you to try to do math that can't be done. I have 3 different variables right now: x's, z's, and y's. Please don't mush them together. They're different factors, so I can't use exponents to talk about them. It's not the same number multiplying out. And so all we're going to do when they're different factors, you're just going to shove them together. Now, I will tell you one thing. It is normal. Catch my language. I'm not saying it's right. I'm saying it's normal to write them in alphabetical order. Now, it's not going to be wrong if you write X, Z, Y. It's just not the way you'll probably see it in your answers, because your test was written by mathematicians, and we, for neatness sake, like to write it in alpha order. So we will write the x's first. We have a single x multiplying. Then I'll write the y's. We have 4 y's multiplying. There's no other y's anywhere in here. Okay, I can't change its exponent. And then we have some z's multiplying. How many z's are multiplying in here too? And again, this is why you guys think algebra is harder than it is. You think I need to keep going, and I'm saying algebra is easy. I stop when the mystery stumps me. Done. I don't have an equal sign, a number over here. I have no clues to try to figure out what X, Y, or Z are. I just stop and drink my tea. That's as simple as that's going to get. This is the end of the experience level problems. So if that's the kind of student you are, experience, if we're starting to feel a little, oh, yeah, okay, this makes sense, but I think I need to try this. Stop the video. You're done. Go pick up the experience level practice. And then for those of you who are like, still too easy, Kate, give me something good. Here we go. Let's get a little deeper. Example 8, find the product of, same as last time, right? I told you what is the product of. All I'm trying to do is intimidate you. I want to intimidate you with my fractions. I want to intimidate you with my negatives. I want to intimidate you with my ugly variable portions, X's, Y's, Z's, but you don't get intimidated because you know exactly what to do. It's exactly the same process. But first of all, this thing is kind of like in Mathglish, half math, half English. Can we just put it in straight math? What did you tell me it means when I find a product?
Multiplication.
Multiplication. So I'm going to take these 3 ugly numbers and write them as 3 big ugly numbers multiplying. So negative 3/8 x squared y fourth times 2/5 x y 6th z, or y to the 6th power z, and 2/3 squared y to the 9th z to the 4th. The most common error here is just writing it down wrong because things start dropping and dancing when they don't have a lot of meaning to you. And right now we have 3 mystery numbers, 3 things without a lot of meaning, X, Y's, and Z's. But ugly or not, I can see there's some coefficients, some plain numbers. What are the coefficients here?
Negative 3/8 and 2/5 and 2/3.
Good. Now, you can multiply this together in your calculator. But since you guys are my advanced level students, I'm actually going to do this by hand because, like I said, fractions were made to multiply. They're nasty to add and subtract, I will admit that, but they're actually easy to multiply. Because it's an act of scaling, the pieces multiply, those are the numerators, but the size of the pieces also changes. That's what multiplication does, it changes size. And so we also multiply straight across the denominator. That makes this simple, and it also makes us able to cross-reduce. If I have a same factor on the top and the bottom, I can cancel them. So 3 and 3, of course, are both divisible by 3. That's easy when they're the same number. So those will just go away. Now 8 and 2 are both divisible by 2. As long as you have a common factor on the top and bottom, you can cancel it out. So I'm going to divide both of those numbers by 2. 2 divided by 2 is 1, and 8 divided by 2 is 4. And even with your numbers remaining, you can do the same thing. I see that I have a 2 on the top and a 4 on the bottom. Those are both even. They can both be divided by 2. 2 divided by 2 is 1, and 4 divided by 2 is 2. Now I'm definitely done because all I have across at the top are 1s. I'm not going to make this any simpler. So 1 times 1 times 1 is 1. And on the bottom, all I have left is 2 times 5 times 1. 2 times 5 times 1 is 10. And there was a negative, so this is still negative.
Or it was 0.1 too.
Brilliant. That's very true. And either one would be right. Once again, it's one of those things that it's not right or wrong, it's just preference. But I'll tell you that most mathematicians, we like to multiply fractions. They're easy to multiply, easier than decimals. And so you're more likely to see this answer in your multiple choice. And now, remember, we're just going to stick on the different variables in alpha order, and we'll just count up how much of each one of those variables we have, one at a time. And we already said we could do that because we can move around things that are multiplying. We can do it in any order we want. So again, we're going to use this to our advantage. So here's 2 x's multiplying. Do you see any more factors of x here?
After the 2/3, there's an x to the second.
Beautiful. That third grouping has some x factors in it. How about the second grouping? Do you see any x's in there?
XY.
Careful. There's an x and there's a y to the 6th power. They're all shoved together, so they're all multiplying. That's x times y to the 6th times z. So this means that we have factors of x. We have x's multiplying in each one of these groups. Now let's count up how many. I have 2 x's multiplying here. I have 1 single solitary x there. Remember, the exponent doesn't jump across the y. And then I have 2 x's there. So that's 1, 2, 3, 4, 5 x's. So I have x to the 5th power. Now, Annette, I just realized why you wanted to call that xy. Because when we were adding and subtracting, we looked at its entire variable portion as one thing, right? But when we're multiplying and dividing, we're on a different playground. We're looking at that thing as a bunch of things multiplying. And so that's the difference between terms, when you look at it as chunks that are adding and subtracting, and factors, when you look at it as chunks that are multiplying. So when you're looking at terms, when you're adding and subtracting, underline the pieces that are adding and subtracting. But right now, I'm looking at a bunch of things multiplying. So I can underline each piece that's multiplying. So always when you start getting lost in the rules and the symbols, ask yourself, am I adding, subtracting, or am I multiplying? That's going to help you break it down. Now let's look at all the y's that are being multiplied in here. We have some y's.
Yes, our first group, we have a y to the 4th power.
Exactly. So we have 4 factors of y in our first group. How about in our second grouping? Well, we see 6 y's multiplying. Now examine the third group. Do I have any y's in there?
Yes.
How many?
9.
9 factors of y in there. So that's a total of how many y's multiplying? 4 plus 6 plus 9, 19 factors of y. Great. Now I don't only have numbers, x's and y's multiplying here. I also have some z's. Now, how many z's do I have? Well, in this grouping, I just have a single solitary z. There's no exponent, so it's just a single z. In the first grouping, of course, I don't see any z's, but I do in the third grouping, not just one factor of z.
There are 4.
Exactly. So I have a total of how many z's multiplying?
That's 5 z's.
Exactly. Or z to the 5th power. Now, here's why you think it's hard and I think it's easy. I'm done. X is a mystery. Y is a mystery. Z is a mystery. I can't multiply anything out. All I can say is there is a negative 1/10, 5 X's, 19 Y's, and 5 Z's all multiplying together. Seems simple to you?
No.
No. And that is why we use exponents to express repeated multiplication. Wasn't that important back when we had 2 to the 3rd power? But when we have y to the 19th power, it just got important. Example 9 here asks us to find the area of the triangle and then simplify our answer. Now, good news is I'd be surprised if you saw this on the GED with finding the area of a shape combined with these variables, these letters. It's a little past the level that they usually test, but I still like the problem because it does review a couple of important GED skills within it. So stick with me. First thing is we've been asked to find what? The area. And we know that anytime we're finding perimeter, area, surface area, or volume, we can hit up our GED formula sheet. So looking at the formula sheet, area is the very first section, and the area of a triangle formula is A equals 1/2 base times height. So all we need to do are find the measurements for the base and the height. And you might say, Kate, there's X's and Y's in these measurements. I don't know exactly what the base is, and that's okay. You can just plug in what you do know. But the important thing here is to know where you find the base and the height of a triangle. So remember, when you're looking at bases and heights of shapes, they're always at a right angle to each other. And that little square is how we mark a right angle in math, and they form a T around the right angle is how I think about it. So those are the 2 measurements we need. Ignore the others, you guys. I tried to trick you. You know how I am. So area is what I'm looking for. That's going to be equivalent to 1/2 of the base, and the base is a side 8.5 x squared. Just sub out B for base with that measurement, as ugly as it is. And then the height there, that goes at a right angle from the base to the vertex, the point. And so that is 10y. And now it might have looked ugly, but this is just something to simplify like we've been doing. So go ahead, do the coefficients first. 1/2 times 8.5 times 10. And you get 42.5. So the area is 42.5. And now we will just tack on our variable portions in alphabetical order. So I see x's. There's an x squared. There's no other x's here, so I'll just smush it on. And then I see a y. And again, there's no other y's, so I'll just smush it on. Now, technically, it is an area, so it is measured in square units. but that's not really the part I want you to take away today. Just that you can write the area as this expression, 42.5 x squared y. That's as far as you can go. All right, number 10, find the volume of a cube with a side length of 3k squared inches. We can hit up the GED formula sheet. Now, I have kind of bad news for you. If you look on the formula sheet and you look for volume of a cube, you're not going to see the word cube. A cube is a type of rectangular prism.
Oh.
Just like a square is a type of a rectangle. But it's a special rectangular prism where all 3 dimensions are the same. If it was just 3 inches, then this would be a 3-inch by 3-inch by 3-inch cube. But it's not 3, it's 3k squared, which means if that dimension is 3k squared, then this dimension is 3k squared, and this dimension is 3k squared. Now, that being said, since it is a type of rectangular prism, we can go to the formula sheet and find the volume of a rectangular prism formula. What is that, Miss Annette?
A volume equal length times width times height.
Good. And now we can substitute in whatever we know. Now, volume is the thing I'm finding. It'll remain a mystery, and equals signs will remain equal signs. But we can replace each one of these variables, length, width, and height, with its equivalent value. Now, you might say, I don't know what the length is. No, but you have an expression that represents it. 3k squared is one way to talk about the length. And so I can replace L with 3k squared because they're equivalent. Substitution doesn't say that things have to get easier. It just says you trade out one thing for something that's equal to it. We also know the width, don't we? They're shoved together, so they're multiplying. The width is also 3k squared. And we also know the height. What did we say the height was?
3k squared.
Also 3k squared. So yeah, it was a geometry problem in that we had to choose the right formula, but now it's just multiplying these algebraic expressions. We can do just like we've been doing. So I have some 3's here. I have 3, a 3, and a 3. They don't have any exponents on them. So it's just a 3, and a 3 multiplying 27.
Okay.
But that's not all I have multiplying here. I have all these k's multiplying. There's 2 k's multiplying, right? That's what k squared means. Another 2 k's multiplying and another 2 k's multiplying. So I have a total of how many k's multiplying?
6 k's?
6 k's multiplying is k to the 6th power. Wonderful. And so now this is done. Now it does have a unit, it's volume, so it would be cubic inches, but that's not really what I want you to take away here. I want you to take away this numeric portion, which would be 27k to the 6th power. Last one looks scary because it's something we haven't seen before, but we can use this rule we've been using to deal with it. So directions say rewrite the exponential expression as a product of like bases then simplify. What I want you to notice is this looks slightly different from what we were doing before. Before, some bases and some more bases. It had numbers on the floor and numbers on the floor. This time I have some bases with some exponents, but this second part, it's just an exponent on a parentheses. And so what this is telling us is that what's being raised to the 4th power is all the junk in the parentheses. I want to compare these two things. Now they look exactly the same, except for the parentheses. Exponents are super duper weak. We've been talking about they only work on the number they're directly attached to. So the 4 in this case is telling me that I have 4 G's. Girl, I
Yes.
wish I had 4 G's. Somebody donate. Give me a cup of coffee because I need 10 G's to publish this book. But anyway, so that's saying that I have 4 G's. Now look at the other one. Do you see how the 4 is not on a letter this time? The 4 is on a parentheses.
Yes.
That means that everything in the parentheses is being raised to the 4th power. And so because of that, I can rewrite this as a product of like bases, meaning as a multiplication expression. This to the 4th power means this whole thing is multiplying 4 times. I have 2f cubed g one time, and it's multiplying 4 times. So there's another factor of 2f cubed g, and another factor of 2f cubed g, and another factor of 2f cubed g. That's all I meant when I said write the exponential expression as a product of like bases. you're not going to see those directions on the GED. You'll just be able to do the math however you wanted. But I just wanted to show you that there was another way to write this so we could use the rules we've been using. Now it's just multiplication. It might be ugly, but we know how to deal with it. So let's deal with our coefficients, our numbers out front first. 2 times 2 is 4, times another 2 is 8, times another 2 is 16. And now I have some f's. So there's 3 f's multiplying, another 3 f's multiplying, another 3 f's multiplying, and another 3 f's multiplying. How many total f's are multiplying?
Wow, 12?
Exactly. That's a total of 12 f's multiplying. Now the G doesn't have any exponents. So that's just a single G, another G, another G, and another G, 4 G's multiplying. All right. And this is done again. I can't make it any simpler.
Sure.
This is just a 16, 12 F's. I'm not writing it out again. My hand hurts. And 4 G's all multiplying together. That's the simplest way I can write that because the F's still a mystery. G's still a mystery. I can't multiply them together if I don't know what they are. The best thing I can do is just say, hey, all these things are multiplying together. Boom, walk away, drink my tea. Great job if you stuck with me all through the advanced level practice. Now, some of you guys stuck with me through the advanced level practice because you're overachievers, but you're not advanced yet. Please go do the level of practice that applies to you. If you're a beginner, do the beginning level practice. It's designed differently for your needs. But if you are advanced, go hit up that advanced level practice. Try to see how this will come up in complex GED and college prep problems. Because if you don't practice, you won't remember it. Super proud of you. Happy learning.